Well done and welcome back. It's clear that Python is a great calculator. If you want to do more complex calculations though, you will want to save values while you're coding along. You can do this by defining a variable with a specific case-sensitive name. Once you create or declare such a variable, you can later call up its value by typing the variable name. Suppose you measure your height and weight in metric units. You're 1.79 meters tall and weigh 68.7 kilograms. You can assign these values to two variables named height and weight with an equal sign. If you now type the name of the variable height, Python looks for the variable name, retrieves its value, and prints it out. Let's now calculate the body mass index, or BMI, which is calculated as follows, with weight in kilograms and height in meters. You can do this with the actual values, but you can just as well use the variable's height and weight, like here. Every time you type the variable's name, you're asking Python to reference the actual value of the variable. Weight corresponds to 68.7 and height to 1.79. Finally, this version has Python store the result in a new variable BMI. BMI now contains the same value as the one you calculated earlier. In Python, variables are used all the time. They help to make your code reproducible. Suppose the code to create the height, weight, and BMI variables are in a script like this. If you now want to recalculate the BMI for another weight, you can simply change the declaration of the weight variable and rerun the script. The BMI changes accordingly, because the value of the variable weight has changed as well. So far, we've only worked with numerical values, such as height and weight. In Python, these numbers all have a specific type. You can check out the type of a value with the type function. To see the type of our BMI value, simply write type and then BMI inside parentheses. You can see that it's a float, which is Python's way of representing a real number. So a number which can have both an integer part and a fractional part. Python also has a type for integers, int, like this example. To do data science, you'll need more than ints and floats though. Python features tons of other data types. The most common ones are strings and booleans. A string is Python's way to represent text. You can use both double and single quotes to build a string, as you can see from these examples. If you print the type of the last variable here, you see that it's str, short for string. The boolean is a type that can either be true or false. You can think of this as yes and no in everyday language. Booleans will be very useful in the future to perform filtering operations on your data, for example. There's something special about Python data types. Have a look at this line of code that sums two integers, and then this line of code that sums two strings. For the integers, the values were summed, while for the strings were pasted together. The plus operator behaved differently for different data types. This is a general principle. How the code behaves depends on the types you're working with. In the exercises that follow, you'll create your first variables and experiment with some of Python's data types. I'll see you in the next video to explain all about lists. Let's get you coding. And I can't wait to see you in the next chapter, where you'll build even more awesome Python chops.